Okay, so we are going to try number 8 on page 158, and we are going to prove that this is a rhombus. So, in order to prove something is a rhombus, there are 3 possible choices. 1, to prove it's a parallelogram with exactly only one pair of consecutive sides that are congruent. Second, again, to prove it's a parallelogram. And if either of the diagonals bisect 2 angles of that parallelogram, then it's a rhombus. Or third, if the diagonals are perpendicular bisectors of each other. So I'm coming back here to look at the picture, and when I look at this picture, I notice that I don't even have diagonals drawn, and if I was to draw the diagonals, that gets to be a bit ridiculous. So my assumption is we are not using any of the diagonals and therefore we want to prove that it's a parallelogram with one pair of consecutive sides that are congruent. So that's how I would kind of work, is I would work backwards. Okay, so first we have to prove it's a parallelogram. Oh look, I see that they gave us it's a parallelogram, so that's easy. So in step 1, they gave us it's a parallelogram. Given, okay. In step 2, they probably told us that YP is perpendicular to TW for a reason. They probably gave that to us. I'm still thinking about the fact that if this is a parallelogram, I need to get one pair of consecutive sides that are congruent. In other words, I need to get the top and the left side congruent. Or I need to get, that was the right and the bottom congruent to each other. Or the left and the bottom, or the left and the top. So as I'm tracing this, I notice that if I can get these congruent to each other, I'm looking at them being as part of these triangles. So if I can get these triangles congruent, then those pink lines are congruent to each other. And if the pink lines are congruent to each other, then it is a parallelogram with one pair of consecutive sides congruent, therefore being a rhombus. So I just have to get this pink triangle congruent to this purple triangle. So that's kind of how I would work this. So when they tell me that YP is perpendicular to TW, I'm assuming I'm looking for this right angle right there. So angle YPT is right. And my reason, again, is if segments are perpendicular, then they intersect to form right angles. I would do this same thing here in step 4. Look at, I'm losing my mind. ZW is perpendicular to TY, and that's given. Okay. And I'm going to come over here, and I'm going to say angle TZW is right. And that is the same reason as step number 3. If 2 segments are perpendicular, then they intersect to form a right angle. And then I am going to say angle YPT is congruent to angle TZW, because if angles are right, then they are congruent. So I have an angle that's congruent to each other. I'm looking at my next given, and it says that TP is congruent to TZ, which helps me because that is a side. So TZ in pink is equal to TP here. And whenever I see triangles like this, remember we've talked about this, where these triangles are called overlapping triangles. And when you have overlapping triangles, you have a transitive angle or a transitive side. In this case, we have a transitive angle. So this purple angle right here in the corner, angle T, is equal to that pink angle in the corner, which is angle T. So angle T is congruent to angle T, and that is the reflexive. I think I forgot my step 7 of given. And therefore, triangle WZT is congruent to triangle YPT. and my reason is angle, side, angle. And after that, we know that side YT is congruent to side TW. And that is because if triangles are congruent, then their corresponding parts are congruent as well. And then I can say that TWXY is a rhombus. And I would say if a parallelogram, and that is in step 1, has one pair of consecutive sides congruent, then it's a rhombus. Okay, and I showed that it has one pair of consecutive sides congruent in step 10. So by referring to step 1 and step 10, we know that this is a rhombus.